But right now, we need to establish results for some basic, some standard functions. The differentiation of some standard function. The first function is a constant function. Now what do I mean by constant function? Let's say my function is going like this, that fx is equal to, let's say 4, or I'm writing fx is equal to c. Now I want to find the differentiation of this given function fx is equal to c. This can be written as y is equal to fx is equal to c. Why I am writing this as y? Because the fx, the value of the function, is denoted on the y-axis. So this is the value of x and this is the value of the function. Now I am saying that this value of function is remaining constant throughout the domain of the function. Now if the value of function is constant throughout its domain, we can see that its slope will be equal to 0. So if the slope is equal to 0, we will say that dy by dx of this function is equal to 0 at all the values of x inside the domain of the function. So for a constant function, fx is equal to c. Now I will write this fx is equal to c is equal to y, right? Because we obtained the value of fx on the y-axis. So I am writing both the physical significance and both the graphical meaning of the function, right? So if y is equal to c, I have this function. In that case, dy upon dx will be equal to 0 because it is a constant function and its slope will not change, right? So derivative, or we can say that differentiation of a constant function is always 0. Now we will see the most important rule in differentiation, which is called the power rule. So what happens in the power rule is, let's suppose I have x to the power n. I want to differentiate x to the power n. So y is equal to x to the power n. I want to differentiate this. So the long way will be that fx plus h minus fx upon h. This will give you f dash x. So at any value of x, the differentiation can be found out like this. But we need to just remember the result. We don't need to solve it every time we get some expression like this. So the common result we obtain from here is that dy by dx of this function is n x to the power n minus 1. So what will happen here is that this exponent n will come in the front and we will subtract 1 from this exponent. So this will become n times x to the power n minus 1. So if the function is x to the power n, then the differentiation or the derivative of the function will be n x to the power n minus 1. So let's do some problems on this one. The first one is x to the power 3. Second is x to the power minus 4. Third is x to the power root 2. Fourth is x to the power minus 4 by 3. And fifth is root 2 x. So just try all these questions. So the formula must be pretty much stuck in your head, that whenever you have x to the power n, any real power of n, any positive negative fractional power of n, then this power will come in the front and we will subtract 1 from this power, right? So let's try to apply this power rule to all these questions. So what I told is dy upon dx is equal to n x to the power n minus 1 if y is equal to x to the power n, right? So the differentiation of the first function dy upon dx will be that I will put this 3 in the front and I will subtract 1 from this power. So this will become 3x squared. Similarly, the second one will become dy upon dx is equal to minus 4 x to the power minus 4 minus 1, which is minus 4x to the power minus 5. So this is the differentiation of the second function. Similarly, the third function, let's see. In this case, dy upon dx will be equal to, you just have to put this root 2 in the front and you have to subtract 1 from this root 2. So this will become root 2 x to the power root 2 minus 1. So this is the differentiation of the third function, which is x to the power root 2. Similarly, the fourth function. So differentiation of fourth function will be dy upon dx is equal to minus 4 upon 3. The power will come in front, x to the power minus 4 upon 3 minus 1. And this is equal to minus 4 upon 3 x to the power minus 7 upon 3. And similarly the last one. Now the last one is pretty important because we have root 2 over here, right? Now root 2 will be treated as constant, so this will come out of the differentiation. Now the function can be written as dy upon dx is equal to root 2 times d upon dx of root x, which is nothing but root 2 times half x to the power minus half, because root x can be written as x to the power half. So this is nothing but root 2 into x to the power half. So the differentiation will be 2 into 1 by root 2, 1 by 2, root 2 into 1 by 2 x to the power minus